All right, we ready? We're on, okay, handout 4 of 7 in your notes. And we're going to talk about the integrated rate law. Wait. It says 4 of 7 at the top. It looks like Greek, doesn't it?
I mean, it looks like calculus.
It is, but we're not doing calculus. Oops. Okay. All right, focus. All right, right now, the last time you wrote rate laws, what kind of data were you given to write that rate law with? What was in those data tables? Molarities and? The rate constant wasn't in the data. You found the rate constant. They gave you the rate. So you were given, and that's why it was initial rates, right? You were given initial concentration and initial rates and asked to find the rate law. All right, the integrated rate law, the data that you're going to be given in the problem this time is going to be concentration and time. Okay, so we're looking at plotting concentration versus time to figure out the rate law. The good news is these will only have one reactant. So we only have to worry about one concentration. In bottom line, if it's a zero order rate law, whoops. If it's a zero order rate law, what does the rate law look like? What does the expression for the rate law look like? Right, because it would be k to a to the 0 power, and a to the 0 power is 1. So it's just r equals k. So a plot of concentration of A versus time will give you a straight line, and that's on your notes, right? Okay, if you look, see the calculus underneath there? See where you see the derivative? I don't know if you know. Okay, so and then they integrate it, right? All right, I don't care that you can integrate and do but there is some calculus, and then poof, basically for us, we get to the integrated rate law, which looks like, in the way they have it written, is like this on your notes. Okay, most of the time you're going to see it. It is negative k. Negative k times t plus the original concentration of A. And if you flip over to the next side on handout 5 of 7, you see it written a different way. But you see that it's the same thing, right? You see A minus AO equals negative KT. Right. O means original, and it's at initial time. Okay. The reason they wrote it on the side that we're looking at like this is because it's in y equals mx plus b format. Right? So what is the slope of that line? Negative k. So I would write on my paper that the slope equals negative k, or k equals the negative slope. Okay, so for these, you're going to plot them, and then you're going to have to find slope to find k. Okay, so if it is zero order, then this graph will come out a straight line. Okay, if I plot concentration versus time. If it is not zero order, when you plot concentration versus time, you're going to get some kind of curve, right? Remember seeing those the other day? You're going to get some type of curve. So we're going to try 2 other things to do to linearize that curve. And the first thing we're going to do is take the natural log. So if you take the natural log of the concentration versus time, let's say it was a curve when you did this one, so like that red curve, but then you plot it natural log of the concentration versus time, and you get a straight line here. Now you know it's what order? It's first order. So if you get a straight line with concentration versus time, it's zero order. If you get a straight line with the natural log or log of the concentration versus time, then it's first order. What does the rate law look like if it's first order? All right, R equals K, right, times the molarity, right, to the first power. That's it. When they do the integration, what does it come out looking like in the y equals mx plus b format? Right. Plus. All right, so you see that one? This is considered, and technically these are considered the differential rate laws, but we drop the word differential. So everything you've been doing has been a differential rate law. These over here that they put on the next one are considered the integrated rate laws. Oops. Okay, does it make any difference? No, because if you have one, you can get back and forth between them, right? There's math to get back and forth between them. We don't necessarily have to use that math to get back and forth, but there is. Okay? We just need to know the two forms. All right, and then what would the rate law be for the first order? The rate law, rate constant, I mean, what would the rate constant be for first order? How am I going to find the rate constant? The slope, it's still slope, right? M is still negative K, right? So again, the slope is negative K, or K is negative the slope. It's the natural log, what? No, the natural log is of the concentration. So the concentration is going to change over time. It's not going to be a 1. It's not the exponent of the concentration. It's the actual concentration. And we'll do them. All right, and then second order, let's just look at that one, and then we'll do a problem, and it'll make more sense. All right, so if we look at second order, what's the rate law? No, but what's the rate law? Yeah, a squared. All right, and then what particular graph should we plot in order to get a straight line for second order? It is going to go up, but it's going to be the constant. It's going to be the inverse, the reciprocal. Thank you, of the concentration versus time. And this time, the line's going to go that way. The integrated rate law for second order is 1 over A equals, whoops, KT plus 1 over A initial, right? You look on that side of the page. That you know, the one you just flipped to. Okay?
Why is that K positive?
Because the line's positive.
Oh, yeah.
All right, so in this case, the slope equals K, right?
Like, what about the one on like the natural law? You said like when it's not in order of 0.
Well, your reactions are either going to be 0 order, and a plot of concentration versus time is going to give you a straight line, or they're going to be first order, and a plot of the natural log of the concentration versus time is going to give you a straight line.
If it's in first order, it's going to be a curved line, so you have to use natural law.
Yeah, and then if that one gives you a curved line, you're going to have to try the next one. We're going to do all three at the same time in Excel. We're going to set it up so it's all done at one time. Uh-huh. Why is there an essay? Yeah, I saw that. I'll have to read it too. Don't worry, I have to grade it too. Don't think about that. It's not an essay. It's like just write a sentence or two. Just
That's an essay.
it says essay, and it takes 500 words because do not.
Can we write an essay?
Now, I don't want to read 5,000 words. Just write a sentence or two that.
You know, I'm gonna make you read a story just so you can get the right answer.
So I'm sort of like writing a story, like in the middle of the story, there's my answers are gonna be there, and then the story's gonna continue.
Okay, I don't want a whole story. Okay, so get Excel out, huh?
You can take that personal.
I can take what?
You can take that personal.
Yeah, well, I'm not going to. All right, get Excel out. Do I just go to Excel? Yes. That would be helpful. I don't think my what you call it will let me write. It might, yeah, not available. That's what I thought. I can't split it.
You like ginger ale, Will? Huh? You like ginger ale? You gotta use ginger ale. So people drink really antichrist? I like ginger ale.
What are you talking about?
Excel goes on forever.
I'm fine, brother.
All right, here we go. You need to plot, but I need to make this bigger. How am I gonna make this bigger? Oh, not wrong thing. Where's my zoom button? Right there. All right, in Excel, it's not gonna let me do it at this. Let me see if I can make it any bigger. I kind of wanted to be able to have both screens is the problem. Can you see that? Is that enough to see? Okay, so in Excel, plot that data or type in that data. So time, and then do concentration. Except I put my backwards one. I don't know. I don't know where it is on Excel. I don't. You have to go to some special place. Who cares?
I cannot read that.
In Excel? Well, I'm just typing the. Sure. Is that better?
Where's the subscript?
I don't know where it is in Excel, and I didn't hunt for it. Just leave it. Oh. Oh, is that why he's singing? Okay, so we need to plot that data because we need to determine, and that's what our question is going to ask us. It's going to say, write the rate law. It's going to say, find the rate constant, just like the other problems did. But we can't do it like we did the other one because we don't have rates. We have times, right? All right, so
But that's really wrong.
let's plot. So plot your data.
Hold on.
How do you?
You go to
Insert. Oh, except I click the button. No, you can't paste somebody to do this.
Of course you can.
Pick scatter plot. You can connect them if you want, but
We don't have an insert.
This is
You don't have what?
You have a different version.
yes, I have a different version than you.
This is not fair.
I have 2016 because I have a whoops. I have a bigger. I don't know. I have a different version of the iOS system than you do. Sorry. So find it. You know where to do charts. Find them. Insert a chart. I'm trying to make mine so you can see everything.
Just go to insert and then chart.
Yeah. Isn't it the same?
And then a scatter plot.
Yeah. You can connect it if you want for the scatter plot, but
Chart scatter.
yeah, you can do.
Yeah, there you go.
Smooth line scatter or smooth mark scatter?
You want the lines?
You can put the line if you want. You cannot put the line if you want.
What type of scatter do you want?
How in all these boxes?
That's crazy.
Look. There you go.
We do not like that. All right. Does everybody have a plot?
You got in there?
And then click scatter.
All right. So this one really would be zero order, right?
Right where you were.
Whoop. Can't spell zero.
And there you go. I did see it.
It's not a straight line. So our data, this is not a zeroth order reaction, right? So guess what we have to plot next? What do we have to plot next? Natural log of the NO2, right? How nice it's Excel though, right? I gotta remember the function. I think it's just ln.
Yeah, functions element.
Is it ln?
Yeah.
Okay, well then I don't have to look.
Element is number. The word. The little.
It's capital L though.
Yeah, capital
Which one did we just do the time?
Ooh, how do we do this?
No, we did the NO.
Equals
It gave me.
ln.
Rate is concentration over time, right? So it's.
No, we're not doing right. We're just doing the natural log of the concentration.
That's magical.
Do I just click on B2?
That's
Yeah.
like the concentration divided by the time.
No, just
Then I click enter.
then click enter, and you should have a number. Do you?
That is, and then
Can we just drag it?
how do we?
Now you can drag it down.
Wait, how did you do it?
And it does all of them.
Wait, how do you drag down?
Are you sure that's a natural log function? Somebody hit it in their calculator.
It
No,
showed,
because it
there's a
wasn't-
little
they're all
thing
listed,
under mine
they're
that
all
showed
there.
up and did it. It said
That's
element
how
there.
that's
Okay.
exactly how that-
Okay.
How'd you do that?
All right, now you have to plot.
Wait, how'd you do that?
What?
L, capital L.
That's right.
How did I do what?
Yeah, that's it.
Okay, how did I do what, Kevin?
Oh, now do we plot it again?
Yep, but we don't need this data in here. We need the natural log of NO2 stuff, and we need time. So make sure you hold command down and just select those two things, right? Then insert chart, same thing. It's command.
I did paper.
What?
Oh, we're good.
So we're just doing time then,
Yeah.
Oh,
I'm
that,
so confused.
that just didn't work.
You gave me two different lines.
Let's do
Uh-oh, somebody catch the thing.
Wait,
Got
how'd
it?
you do that element thing? Here's the keys.
What?
This sounds very scary.
What?
I'm putting a completely different gas in every single time like I put on the scale box. It's giving me the same one, but like it has it's really weird. Like it doesn't have any points on it. It worked the first time and I did my same thing. It didn't work and it didn't work.
What? Are you getting any points?
For the first one I did, but then the second one I did the exact same thing with the scale box. It had like the series 150 for like the different colors. And then
Did you pick scatter or did you pick line?
yeah, I picked scatter and I did like the same
All right,
color.
so it doesn't like the data. Is what it is it doesn't like the data. So you're gonna have to go into select data, wherever that is in your chart design. You're gonna have to go to select data and then literally click on the things that you want to be the X values,
That one's
and then go click on what you want to be the Y values.
Wait, Mr. Robinson, can you repeat how you got it all to like go down the road?
Oh, here?
Yeah.
Like if these aren't here, whoops. Like if they're not there, if you have this one in,
Yeah.
there's a little, see that little square down there? See how my icon changes or my little cursor changes? I can just pick it up and drag it.
Hold on.
All right, so is that one a straight line?
No.
No, so this would have been our first order. All right, so what do we have to plot if that one's not a straight line?
One divided.
One divided by.
1 divided by. So this is going to be our 1, and if you don't, well, hopefully it will still pick it up as text. All right, this is going to be NO2.
What is your sub one?
Why is what?
Your graph. It has one at 0.
I have.
That'll be the
Oh,
same
it's not
thing.
plotting the right thing.
Isn't it because it's 0.1, so it's
That's what I have. It's
Oh,
not-
because it's at time 0. It's flipped. Mine's flipped. Mine's flipped. I was like, yep, you're right. Okay, look. You should be able to, well, let me see. Did I pick X? Probably when I went back to show him. No. My X is my time.
Mine goes down.
Mine is always down.
I don't know. Oops.
Is that 1 over 1502?
It does look like it's flipped funny though, doesn't it? I don't know what it did.
When I did this,
Because the first thing it should
third
have
graph that we
negative
did,
2.
I got
Whatever.
I don't know unless I clicked on something. Oh, it's trying to plot this nothing up here.
You have 6 points.
Yeah, it's trying to plot that right there.
I'm having trouble.
So, okay. So if I go back in and select it, I clicked on the header and didn't tell it I had a header, basically. Oh, except I'm supposed to be doing this.
Can't bring you an issue the second one.
Huh?
I'm having issues with
So what's the formula we use for this?
this.
What is the formula used for the next one? There, is that better? Sorry.
1 divided by.
Yeah, so equals 1 divided by, what's it going to be divided by?
you have that highlighted.
B2 or the, yeah. And drag that down. Okay, because I'm recording, let me finish it and then I'll come around and help y'all. All right, and then same thing. We need to select our stuff for our graph. So we want that and this. Yep. Yep.
If you don't get the words, it gives you like a bunch of series and it looks very confusing.
So highlight the words too.
Yes, ma'am.
Yeah, look.
But like how I adjust the data.
Wait,
I'm
hold on.
making like a bunch of series.
What
and
did
they
you
were all
write?
the same length.
Yeah.
Right.
Different color symbols.
Yeah, that doesn't help you.
I missed that. What did you do?
Oh, 1 divided by the NO2 for the formula. Is that what you missed?
Yeah.
Or
you're
the,
right.
yeah, the formula is 1 divided by B2. Yes,
You have to write that equals.
yes, or it won't know it's a formula.
1 divided by.
B2 or wherever you're first.
Can I click on it?
Yeah, somehow I drug mine way over to Timbuktu over here.
Well, I got a straight line.
Okay, so what order is our reaction?
Second.
I keep dragging it over.
So do
It's
we get to
second
use
order.
this
I
on
can't
the
do it
test?
in this little
First
bitty.
one,
Huh?
Do we get to use this on the test?
You don't get to use it on the test, but you do get to use it on your homework. So now you have a nice little Excel spreadsheet set up. Guess what you don't have to do anymore? You don't have to put those formulas in anymore because you've already done them, right?
What is fit? What's
So
fit?
Well,
Okay.
the way it's going to look on a test or a quiz will be that I either already give you the plots and say write the rate laws, or the question could say, for this second order reaction, what plot would give you a straight line, or what should, or it would be phrased more like that. You do not have to plot them on a test or quiz or the AP test. Generally, because some kids have graphing calculators and could plop it in really fast, and some kids it would be forever, right? So it's not fair. So usually they just give you the pictures of the graph and ask you to write the rate law. Okay, so do you have a line yet?
Oh, is it even like a bunch of different series, Kevin?
Yeah, it's gonna be a bunch of series. I'm just like waiting.
All right, the next thing we have to be able to do, because we're going to have to write the rate law, we can do that part. What's the next thing I'm going to ask you to find? That rate constant, that K. Right, how are we going to find the K for that second order reaction? We need the slope, right? But Excel will do it for you, right? So if you're clicked on your graph, you should be able to find somewhere in your chart design or format. We need trend line. Do you see trend line anywhere? I think it's in chart design, but I don't have mine big enough to see.
We don't even
Yeah,
have
chart layout is
design.
right there.
Chart layout.
Uh-huh.
Okay, there should be a trend line somewhere. I'm not seeing
Or if
mine.
you just use it as a marked scatter, then it'll draw the line for you.
I don't want it to draw the line. I want the function. If you see this, like you could pick one. This one actually has the function on it. See how it says f of x? So if I click that format, it'll give it to me.
What format did you just click? I didn't see that. What does it say?
It has an f of x.
Oh, it doesn't even say.
You want a linear, because now that we're on the straight line, you want a linear regression. That's what you're doing. So trend line, linear, and then click off. You're going to have to check off on the options or something below that you want that trend line, and I don't know if you want the r squared value, but check off the line. The r squared value, the closer it is to 1, the better your data is. I don't know where it is on mine. Oh, there it was. Add chart element. That's where it was. It was in this one for me.
Ours doesn't
Here it is. Trend
say
line.
this.
I go to more trend options and then pick linear. Yours looks different, but then you can tell it to display.
Where do you see to tell it to display?
Go when you're in trend lines,
Uh-huh.
Display
go to
equation.
more trend line options instead of just checking off linear.
So it says format trend line. There we go. And then I see like linear, logarithmic, polynomial, all that.
So
Go
pick-
to options.
Then go to options and then check off display equation and display r squared value.
Okay, display. Oh, I see. Okay. Yeah, okay.
All right, so what's my rate constant?
Your rate constant is
10.16.
Oh, ha 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 ha. Yeah.
Right? Y equals mx plus b. 10.16.
Wow, okay. Well, that's useful.
It is useful. It's handy.
You know what else is handy?
What?
Anarchism.
You can do a linear regression without it being on the graph too, but that's irrelevant. Okay, I'll just drag that over there. All right, so that's what you need. The only other thing that you need with the integrated rate law is half-life. The nice thing with the integrated rate law is, yeah, save your Excel file. Save it now so when you close your computer, you don't lose it. Because there's about 4 or 5 of these that you have to do for homework, and so on Mastering Chem. So you just drop your data in there, and really all you should have to do is drop your data in time and concentration, and the rest of your spreadsheet will fill itself out.
Will the graphs like
The
change
graphs
themselves?
will update, yes.
What?
So all 3 graphs, immediately you'll be able to see which one's a straight line. Now you'll have to go put that linear regression in, either go put that linear regression in all 3, so it's always there, or you'll have to put it in on the one that's a straight line.
Wait, so you said we should enter this stuff into this actual chart and
Mhm.
things will change?
Yep, absolutely. It is. It is. So that's where that'll save you a lot of time on your homework, right? Huh? What?
It's 156.
But we get out at 2:01 because we're on activity schedule. So I have a minute or 2. All right. I do not think I put very many, but I do think I put one that has to do with this time. Uh-huh. Huh? What do you...
That's 10 to whatever.
Magnitude is just the number. It's just the value with no sign, no plus or minus sign. It's just the number. All right. The other thing you're going to have to be able to do, flip to the other page that says page 5 of 7, is this half-life stuff. What is half-life, by the way? What did he say?
Is that how long it takes one thing like lose half of the time?
Yeah, right. So it's the time for half of the sample to decay.
We were doing something like the decathlon state test was yesterday on the science test. One of the questions was, it only has a half-life of 2,000 years. Only 2,000.
How long you take an element to decay?
Yeah, well, some of them are millions. Yeah, some are long. Okay, so time for half of the sample to decay. You can use the integrated rate laws, right? And you have 3. This one is for what order? 0 order. This one is for first order. And this one is for second order. Right. Okay. So if the half-life is defined as when half the sample decays, what could I put in for time, or not time, concentration original and concentration at time t? Is that y'all already? That's wrong.
No, I think it's us.
That's not.
It's still wrong. You're not supposed to leave till 2:01. Okay. Anyway, if you're given an amount original, you're given a time, you can solve for another amount. If you're given there's this much left at the end and you started with this much, you can figure out how much time went by. Okay? You can rearrange these equations to get those half-life equations that are on your paper as well. That's what I was going to derive for you, but if that's the bell, then I won't derive them. You'll just have to take them on faith. All right, you have a Mastering Chem. You also have a quiz next time. So, quiz on rate laws, the stuff you did last time and today.
You're going to be reading into essays, by the way.
And Mastering Chem.
Copy paste the movie script.
Do not put script in there.